We're going to put a point on here, and then I'll show you how to convert it to Cartesian coordinates. So let's choose a point here, oh, right there, okay? So that point right there, we'll call this point A. And point A is going to be, if we look at the coordinates there, point A is a radius of 1, 2, 3, 4, 5. So 5 units. Each of these would be pi over 12 because it's half of pi over 6. So if I just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, this is actually 15 pi's over 12. And then I can reduce that by taking out the 3. And so it's 5 pi over 4. Now you may have already known that though, because it was halfway between pi and 3 pi over 2. So if you had been thinking about it, it was 5 pi over 4. There's another way I could write this though. So I also want you guys to know that A could also be written in a different way. Because instead of doing 5, I could have done -5. And then if I went to the opposite side, over here, this is actually pi over 4 right here. So pi over 4. So these are both point A. You can write them both ways. So it doesn't matter whether you're on the positive side or the negative side, you're always going to be able to write points in polar graph mode in an infinite number of ways. Because I could also rotate all the way around and do another angle, and it would be a bigger angle, but it would be the same point. So there's always many ways to write the same point in polar graphing. So I could also do 5. If I added 2 pi to 5 pi over 4, that would be 8 pi over 4 plus 5 pi over 4, so it'd be 13 pi over 4. So that's the same point also. All of those are point A. But that doesn't help us convert it to Cartesian coordinates. So to do that, what we're going to do is we're going to imagine a triangle here. So if I think about Cartesian coordinates, we only go horizontally and vertically. And if I was to draw in a triangle here, only going horizontally and vertically, well, whoops, here is a triangle. It's a right triangle. It probably looks very familiar to you. And then I could use this triangle to figure out exactly what the Cartesian coordinates of point A are. The way that I'm going to do that is by looking at the fact that there's an angle right here. If I have an angle that rotates around like this, do you guys remember that X and Y are directly related to this angle? And the way that I can figure that out is by using the definitions. So I know that sine of theta is equal to y over r. Well, I'm trying to find y. So what can we do to both sides of that equation to get y by itself? Times by r. So then y is equal to r sine of theta. And then if I do the same thing with cosine multiplied by r, then x is r cosine of theta. So it turns out that for any r theta, we can rewrite that point in, so this is the polar point. Then to write it in Cartesian coordinates, I would use, well, x is r cosine theta, and y is r sine of theta. I can take any point in polar and I can convert it to Cartesian by using that relationship right there. All right, so knowing this, then we can go and take our information from our problem. And so I can find out then that the point A, 5 pi over 4, is the same as calculating 5 times the cosine of 5 pi over 4 And then for sine, it would be, or for the y value, it would be 5 sine of 5 pi over 4. You can use a calculator for this one, but it's actually faster just to use your unit circle. So if you go to your unit circle and look, you'll find that the cosine of 5 pi over 4 is negative root 2 over 2. And so if I multiply 5 times negative root 2 over 2, I end up with negative 5 root 2 over 2. And then if I take sine of 5 pi over 4, that's still negative. The y value is still negative. It's also root 2 over 2. So then it would be 5 root 2 over 2. And so this would be my exact Cartesian coordinates. And so if you're given a point in Cartesian coordinates, can you convert it to polar coordinates? All right, so let's take a look at one in Cartesian units. So we'll just take some point, let's say this point right here. Okay, and if I look at that point, I'll call this point B, and it is 1, 2, 3, 4, 5, 6, 3. But anyway, we've got this point, and we want to convert it to polar form. So if I was to do the same trick that I did last time, we'll just think of this as being a triangle. The relationship between this distance right here, so here's my R value, here's my X, and here's my Y. I know that X is 6 and Y is 3. So I have those two pieces of information. But I don't know if you guys remember this, but R is always the square root of x squared plus y squared. So I can always find that. Finding R is the easy part. So when we go to find R, we're going to just calculate R out using basically the Pythagorean theorem. And so in this particular problem, R would be the square root of 6 squared plus 3 squared, which is the square root of 36 plus 9, which is the square root of 45. That has a perfect square in it. Oops. And so that's, let's see, 3 root 5. That's part of our coordinate. So when we write our polar form here, we've just found our R value, 3 root 5. But now we need to find the angle. And the way that we usually find the angle is by thinking of an equation. We know that whatever angle this is right here, that, let's call that theta, I know that the tangent of theta is equal to what? Y over x. Okay. And then I can, once I have that equation, I can solve for theta, but I need to remember that there's actually two possible places where this equation could be true on a coordinate system, because if y over x was positive, it could be in quadrant 1 or it could be in quadrant 3. If it was negative, it could be in quadrant 2 or quadrant 4. So when I go and solve this equation for theta, I will have to keep in mind what quadrant my point is in. But we'll start out here. We know that tangent 3 over 6, so that's 1/2. And then how would I solve for theta? Inverse tangent, okay? So if I take inverse tangent, that's not a tangent. Inverse tangent of both sides. And that 3 over 6 is just 1/2. And if I do that, go to my handy dandy calculator, and I can either do it in degrees or radians. I just need to make sure that if they asked for a specific system that I'm giving them the system or the units that they wanted. So I'll put my calculator in radian mode then, and I get 0.4636476 blah blah blah. So it's about 0.4636, and that would be in radians. Then I need to look at what quadrant I'm in. And if I was over here, so if this was my point right here, so let me use a different color. If I was in this quadrant, then what I would need to do, this angle from here to here would be half a rotation beyond where I currently am. So if I was in quadrant 3, then I would need to add pi. Yes. So what you've actually found here is the reference angle. That's exactly right. Okay. And then if you're in quadrant 1, then your reference angle is exactly the angle you have here. If you're in quadrant 4, the reference angle will be exactly what you need. But if you're in quadrant 2 or 3, then you'll need to make an adjustment. You know, tangent will only give you answers that are here or here, inverse tangent, but woo. And so if you're in here or here, you'll have to add pi or subtract pi. Yeah. Okay. But in our case, we don't need to do that. So I could add or subtract pi, and I would end up with something in quadrant 2 or quadrant 3 if I'm going to do that. But in my case, I'm okay being quadrant 1. And so for our answer, it would just be 0.4636. And we'd be done. So here we have the point -7, 7. And I keep hitting the erase button on here. In this case, the point that I gave you, it's actually possible to find an exact answer, because if I go and do the same things that I did before, so r is still going to be the square root of x squared plus y squared, which in our case, it's 7 squared plus 7 squared, which is the square root of 98. And 98 contains 49, so I could split it apart like that. And so I'd have the square root of, I'd have 7 root 2 then for r, so that's our exact r value then. And then to find the angle, I'd go tangent of theta is -7/7. Oh, whoops, other way around. Y over x. And so then I'd get -1 for that. So tangent of theta equals -1. And then if I go to my unit circle or to my chart or to my study guide, I would find where tangent of theta is equal to -1. And if I look through my chart, or if I was to look at a unit circle, so let me turn off the Cartesian grid just for a second. I go find where tangent of theta would be -1, and that's, well, if you look here, -7 and 7 is going to be here. That is a tangent value of -1, and so is this over here. So my two possibilities would be 315 or 135 degrees. So it's either 135 or 315. But we know that we were in a certain quadrant. We were in quadrant 2. That means that it can't be this one. So then theta has to be 135 degrees using my chart. So if they're asking for exact angles, it means the angle that they've given you, or exact values, the angle they've given you is a nice angle, and you can look directly at the unit circle to figure out what angle meets the criteria for tangent. And so then in our case, our polar coordinates would be 7√2 and 135 degrees, or if it was in radians, then you'd give the equivalent for radians, which would be in this case 3 pi over 4.